All right. Welcome to the last talk session here of the day. We are very pleased to have Rae Knowler here, who will be talking about Python locales and writing systems. If you have any questions, perhaps you can catch Rae afterwards. We're not going to have time to have questions here, okay? So here's Rae.
Hi, thanks everyone, thanks a lot. This is a pretty big room, but I'm just gonna go for it. Okay, welcome to this talk. Before I go into my actual topic, I'm just gonna tell you a little bit about me. As Ned already introduced me, my name is Rae. That's my Twitter handle up there. It's just my name. It's terribly imaginative. I'm a web developer who is British but based in Switzerland, and I mostly do Python, PHP, and kind of dabble in Go and JavaScript. I work for a company called Leap AG, and they sponsored me to come here today, which is really kind of them. And I use they pronouns, or anything non-gendered. I thought it would be a bit pointless to put a picture of my lovely face on this slide since you know what I look like. So this is beautiful, sunny, green Zurich, where I'm based. This is possibly the most important slide in this whole talk. These are the languages I speak. I'm a native speaker of English. I speak reasonably good German, having lived in a German-speaking country for a while, and I am learning Swedish and Spanish on Duolingo. What this means is that I don't actually speak, certainly not natively or fluently, any of the languages we're going to be talking about in this session. So if I make any terrible slip-ups and you speak one of the languages, I would really love it if you came to me at the end and kind of corrected me, but I'm going to do my best. So, to get started, everyone here is using Python 3, right? Yeah, anyone still using Python 2? Okay, you're probably going to have to get a move on, but I know there are reasons why you probably can't switch right this second. But I'd like to talk a little bit about one of the many excellent things about Python 3, which is that by default in Python 3, all strings are Unicode, whereas in Python 2, they were ASCII. And ASCII is really just it's a set of characters, which is the capital letters and the small letters of the Roman alphabet, numbers, some punctuation and stuff. And you know, this is great if you are an English-speaking person learning to code in an English-speaking place, which was me 6 years ago or so. And also, I won't get into what encoding necessarily means in this talk. I've got some links at the end if you want to do a deeper dive into Unicode. Python 3 also just assumes that your source files are encoded in UTF-8, which is a sensible value. And this means that if you are dealing with text strings and you want to include something that's non-ASCII, so you know, to write the word cafe, for example, with an accent on the E, or to write something in German or French, where there's quite a lot of other accents, you don't have to specify that it's a Unicode string. And if you're like me, English-speaking person in Britain learning to program, and then you move, as I did, to Switzerland, and get your first job as a programmer, which is basically munging strings that you've scraped off the web, and they're all German and French place names. If you start with Python 3, you will see a lot less of this error message. And you'll be a lot less confused and like, oh God, I thought I could program, and now someone is paying for me, and it turns out I'm terrible at this. So yeah, Python 3 is good. However, there are a lot of cases where you might want to localize text using different alphabets than the Roman one, the Latin one. And then even though you are dutifully using Python 3 and relying on its Unicode features, you can still get in trouble. How much trouble? Well, I mean, you could end up like these people. This is Ramazan Chalchaban and Emina Chalchaban. I hope I'm pronouncing that right. They were a young married couple in Turkey a few years ago. And they are now, I'm afraid to say, both dead. You see, the problem they were having was that they, quite young, I guess they were early 20s, and they got married. Things were fine for a little while. And then they started having arguments. They split up. Emina was living back at her family's house, but they couldn't leave it alone. You know, anyone who's been in a bad relationship that broke up can probably identify with this a bit. They were texting each other all of the time. It's like, but you said this, you said that. And then one day, Ramazan unfortunately sent a text message, which translated to something like, you always change what you're saying when you run out of arguments. The problem was he sent it from his phone, which included the dotless Turkish letter I. You can see that in the title there. And he sent it to Emina's phone, which didn't include this GIF. Like, her phone just couldn't handle it, so it represented it with a normal, what we usually use every day here, dotted I. And that meant that his nasty comment to his soon-to-be ex-wife turned out something quite obscene. And she was horrified and infuriated, showed her whole family the text message. They were also horrified and infuriated. Ramazan came over, they met him at the door with knives, and then in the ensuing kind of confusion, both of these two young people ended up dead. Out of a complete accident to do with character encoding. Now, as far as I know, neither of the cell phones that they were using had any Python in their actual source code. I presume not. But I'd just like you to kind of remember that sometimes character encoding is not just like an annoying consideration that you have to keep in mind, because otherwise nerds like me will come and tell you off. It can be quite important. Also, now that we've sort of gone past the Chalchaban family, no one else in this talk will die. Unless like anyone in the audience is not well, but I sincerely hope you're all well. Okay. So, as I say, they weren't using Python, but we are using Python, and we might want to work with the dotless and dotted I. You can see the 4 letters here. I hope that's legible. You have a dotless capital and small I, and you have the same 2 glyphs for dotted. And each of them has their own Unicode code point. And of course, if you capitalize a dotless I, it becomes a dotless capital I, and it should decapitalize the same way. Unfortunately, there is a bug in Python, which the last time I gave this talk, someone told me very, very sincerely that it had been fixed, I think in Python 3.6, but actually I believe it hasn't been fixed yet. Where if you, say as I did, you set your locale to Turkish, UTF-8, and you make an array of the 4 letters I, then you might want to, say, capitalize them all and then decapitalize them all. And as you can see, if you read through my output there, in Turkish, even using the right locale, it just goes wrong. A capital dotless I always goes to a small dotted I, and vice versa. So yeah, actually, if you're dealing with Turkish texts that you might want to just put in different cases, you could be setting yourself up for a very bloody accident. Oh, sorry, I seem to be missing a slide here. I will just summarize what I was going to say, which is there are two ways to get around this with Python. And one is to just make a translation table for yourself of the correct relationships between capitals and dottedness, and use that when you're translating text. And the other is to I'm terribly sorry. I missed a slide, and the slide had my speaker notes on it, and I've now forgotten the name of the library I was going to tell you to import. But there there is a third party.
IBM?
Yes, thank you.
I don't remember.
Oh, come on. How many core developers do I have here? Could be. OK, so I have my researchers in the front row trying to figure this out. Thank you. Yeah, there's an external C package that you can... Thank you. Can I have a round of applause? Thank you so much, guys. Yes, you can import the ICU package, and that will allow you to correctly capitalize and decapitalize Turkish. However, if that's the only thing that you need it for, I would suggest going with the small hand-built translation table, because that's a pretty heavy thing to include in your project. Yeah, just be aware of this. And my partner makes a game in Java, and he actually had a really annoying bug, which was caused by this exact same thing. So it's definitely something to keep aware of. OK, so unintentionally, this talk is kind of structured as an west to east journey around the world. And so our next stop is going to be in Israel, because I want to talk about right-to-left writing systems. And the picture I picked to illustrate this is a street sign. I really like it because you can see from the font size exactly what's going on there. The transliterated name of the street is Simtat Aluf Batzulut, and the same thing is written there at the top in Hebrew, right to left. How do we handle this as programmers? We have to be aware of something called the distinction between logical and visual ordering. Unicode doesn't really want to care about whether we're writing left to right or right to left. All Unicode cares about is the logical order. So like, if I am a person reading this string, what order do the letters go into my brain? Makes sense. However, when we're outputting this for humans to read, we need to take account of the visual order, obviously. We need bidirectional support. And that's not natively in Python, but luckily there's an open source package called Python BiDi, or BiD, I'm not quite sure how that's pronounced, which will handle it for you. You just pip install it. And then you can see that we have a Hebrew string here, which is written, it's represented here left to right in the order of the characters, like the logical order. And yet, if we get display, then we output it in a normal output Hebrew way. And the string here says, Academy of the Hebrew Language. I thought that would be quite an appropriate example. OK, we have conquered right-to-left writing systems. That was very easy. We installed one library, and we are doing good. Until we switch country, or we sort of walk along a bit, and we meet someone who would like us to write down some stuff in Arabic. Arabic, as you probably know, is also a right-to-left writing system like Hebrew. But it's more complicated in that the letters have different forms depending on where they are in the word, like whether they're just on their own, whether they're in the end, middle, or the beginning. And the illustration I have here is just a screenshot from the Wikipedia page, which gives some examples of how much the shape of the letters can change. Oh, yeah. And just as a side note, there is a really, I mean, if you speak Arabic, or if you're interested in this, there's a really funny blog called No, That's Not Arabic, which just shows lots of examples of stuff where, you know, like video games, advertising, sort of signs that people have posted up to give a kind of international feel, where people have just written some text and like put it in an Arab font, an Arabic font, and just assumed that it's then Arabic. But it's not, because most of the time it's accidentally been reversed left to right, and pretty much all of the time they don't consider these contextual forms, which leads to some really weird examples sometimes. There's a link at the end of this talk. Okay, luckily, we have an open source library here to help us as well. This is Python Arabic Reshaper. It's a Python library that took its start in, I think, Android libraries. So it's been sort of pulled over for us. And it's very easy to use. I will just give you an example that's actually on their website. You take a string of Arabic letters, which are the correct letters, and it then puts them into the correct shapes. So yeah, that's now legible if you're an Arabic speaker. And this says, Arabic fantastic. Seems, yeah. Seems appropriate. Okay. We're now going to kind of skip over several countries in our Round the World tour until we get to East Asia, because I want to talk about full-width and half-width characters. You probably do notice a difference between the two strings that are there. One is a lot wider. And in fact, if you happen to have looked on Japanese or Chinese websites that include English text, the exact sort of aesthetic style of the top line will probably be quite familiar to you as well. Here's another one. This is just a random font off my computer, and you can see that the upper line doesn't even have any style to it. So yeah, as you can probably guess, the top line includes full-width characters, and the bottom line includes half-width characters. What are these, and why do we have them in fonts, and why are they there in Unicode? This doesn't make any sense. It makes sense if you need ever to write in Chinese or Japanese, or actually Korean. And there are several different alphabets we might use. These are Han characters. They come from they come from Chinese, but they are also quite often used, just kind of imported in Japanese and Korean. And they are full width. You can see they generally look like little squares. Then these are kana, and these are Japanese characters. And this is really the only place where we might have to deal with both full width and half width characters. You can see, obviously, full width on top, half width on the bottom. And these are usually the characters used in displays, electronic displays, like on the till in a shop. They were originally kind of square-ish, like the Han characters, but you can squeeze more in if you make them half width. And so that's what people started doing when they were working on electronic displays. And you can see they're all pretty simple, so you don't lose a lot of information if you just squeeze them. And then we have hiragana. That's another set of Japanese characters. They're kind of round instead of square-ish, like the kana, and they're also always full width. There are Korean characters as well, but I'm going to pick those up in more detail in a second. So here's how you write in China or Japan. And if you want to include Roman letters in there, as in this example, you can tell that everything just looks way nicer, much more legible, much more kind of open and uniform. If you treat the Roman characters as if they're also full width, and sometimes this means sort of changing the shapes of the letters. Sometimes it just means putting more space between them. So yeah, that means that as well as kana, Roman letters also have full width and half width versions. And if you are writing a Chinese website and you think, oh yeah, okay, this bit, like this contact page, has to be written in English as well or in French, whatever, you just kind of look for the Latin letters in your font and kind of put them in, which means sometimes people end up using the full width characters just for several whole paragraphs of English text. It also means that font designers for Chinese and Japanese fonts usually don't put nearly as much design work into these letters as into the ones people will use every day, which means you often get this kind of very neglected-looking, sort of wonky feeling, kind of ugly aspect to text in English on Chinese websites, and I have to say, I love it. Like, there's something about it I just really enjoy. Okay, so we know what these are, and we know why we want to deal with them. But how? How can we do this in Python? And once again, it's just a pip install away. There's a really great library called JA-conv, which will convert text between full width and half width. It works on Roman letters as well as hiragana and katakana and so on. And it does a lot of other different conversion as well. But for the purposes of this talk, here we are. We have, the top line is we have a string of kana that are hankaku, or, sorry, I've written this the wrong way around. We have at the top a string of Japanese kana which are zenkaku, full width, and we want to transform them into hankaku. So we use the JA-conv method Z to H, zenkaku to hankaku, and then just to reverse, we have H to Z. So that's very simple. And you can see it also works for Roman characters. You just have to tell it these are ASCII. So I guess actually that means it works on ASCII. I haven't tried this with accented characters. It works quite easily. One thing I'd just like to point out is that you can see in the second line there, where we have the full width string, the space in the middle is actually a Unicode glyph, which has the code point 3000. And that is called the ideographic space. It's wider than a normal space, and it's just one of sort of many invisible species of Unicode characters. Obviously you wouldn't normally see it. Now you can see it, like with X-ray. Okay, I don't have that much longer, so I might have to speed up a bit. I told you I would pick up on Korean text, and here it is. The Korean alphabet is very special. It's not really an alphabet, it's a syllabary. It was developed at the court of King Sejong the Great around the middle of the 15th century, and it's still used. And this is one of my favorite sort of historical stories. Before this, the all-Korean writing was done in a very different style. It was more pictographic, like Chinese, and very beautiful, but took a long time to learn and a long time to read and write. And so Sejong just said to his experts at the court, I don't like this. This is not efficient. Please design me an efficient alphabet. And they went away, took some time, and this is what they came up with. And now everyone uses that. You very rarely see the old style of writing. So how does it work? The different multicolored signs that you see here are different letters, basically. They each represent one phonetic sound. So we have the yellow h, we have the A, which is that long, or A, I guess, the long figure there in blue, and then underneath that N, N. And then on the other side, we have G, L. And so taken together, and so we organize the phonetic sounds, the phonetic symbols, into groups of 2 or 3, which are then really the actual letters that are printed and written. And taken together, this says Hangul, which is the name of Korean writing. Okay. Here's a page that has a lot more detail, probably more than you can take in, but it's really interesting. And now I have to talk about Unicode equivalence for a while. You see, there's lots of ways you can write the same thing, and lots of ways in which you can write 2 different things that might actually mean the same thing. And this becomes relevant when we're writing in Korean. You see, in Unicode canonical equivalence, this means you can build the same character in several different ways, and they mean the same thing. So Han, written with the syllable block, means exactly the same as Han, just written with 3 letters. And there might be cases when you're writing in Korean when you would write the letters separately like that, although it's not the norm. So yeah, those mean the same thing. And that means that we can write the syllable Han in 2 normal forms, as they call it. The decomposed one, all the letters apart, and the composed one, where you write them all together. And in fact, to use canonical equivalence, you decompose all of your text and then recompose it into the sort of most standard way. Here I am with a Korean string. This is just vanilla Python 3. And so for each character in that string, there are 2 characters. I just want to print the decomposed normalized version of that character. Start with 2 composed syllable blocks, and I end up with 2 strings of 3 letters. Cool. And yeah, then I take it and I just print the composed normal form, and we see what we would expect, 2 syllable blocks. Now, Python handles this correctly, but the thing that you have to remember is that when you're writing an app or a website or something, it's not just your Python code that all of your text and information is going to flow through. This is what I noticed when I was messing around with this, just in the terminal, as you can see. So I wanted to print, I wanted to use the Unicode data library and normalize my string in the decomposed fashion. So if we go back, you can see, yep, my string is 2 syllable blocks. I want to decompose it into 2 strings of 3 letters. And then when I print this out, sort of all on one line, not doing it character by character, what showed up in my terminal was actually this, which doesn't look like this. I expected just 6 letters, but what I got was kind of a mesh, something like this. And I think that's because the terminal I was using, sort of, it knows, oh yeah, okay, so Han, that's 1 letter, 1 character. And we're going to print Han, and then we're going to print Gul, and that's also 1 character. So it gave itself the space to print 2 characters. But because this was decomposed, it was actually needing to print 6 characters. And it just kind of put them all on top of each other. You can tell that Python is doing the right thing here. If I just show you how it looked when I just saved it to a file, that's exactly what I wanted, the decomposed characters. Okay, so I have less than 5 minutes left. We're now going to talk about security. Pretty sure we can fit this in, right? Okay, no, I don't think so. And I'm going to have to rush. So I'm just going to give you a couple of tasters of the way we need to pay attention to Unicode issues when considering security for our websites and apps and so on, which, of course, we always should. So the first is SQL injection. Most of the time when we develop for the web these days, we're using a framework and an ORM, which should, if you're using them correctly, take care of this stuff for you. But people don't always. And yeah, you still need to know it. Okay, so when we deal with a string, to show, to write down that it's a string, you take the characters that, say, your user has typed in and put them in quotation marks. The user types in, I don't like raisins, and we represent this as quotation mark, I don't like raisins, quotation mark. Of course, since we might also use an apostrophe in the string itself, we escape that with an escape character, usually the backslash, depending on what exactly we're doing it with it. Okay. The backslash is, of course, a character. It's represented in Unicode, and it has a code point, which, if you hex encode it, is 0x to show it's a hex encoding, and then 5c. Great, okay. The problem is, as you get further up into the, along the Unicode code points, if you're just, 01, 02, 03, whatever, that's fine. We can encode that in just 1 byte. But as we get into characters that are added further up in Unicode, we start needing to use 2 or 4 bytes to represent them. And here we have a Han character, actually, which means grain, or grain ready for threshing. I just picked it completely at random. And you can see we need to use 2 bytes to encode that. So it's OXB8, OX5C. Now, if I, as a user, input the character which is encoded as OXB8, and then an apostrophe, and then some SQL language into your system, and I've written this as OXB8 just for kind of for clarity. I think that character is actually a spacing cedilla, like the little tail that you sometimes see on the bottom of letters, just the tail. Okay, I will explain this and then I'm done. Thank you. Okay, so say I put this in, and you very cleverly escape the apostrophe there with a backslash. Now, when I read the string through, like in my code to talk to the database, I see OXB8, OX5C, which is to say grain. And actually, the input here is grain, or 1 = 1. And so if I just pass this into my database as part of a query, like give the phone number of the user where the user's name is blah, or 1 = 1, then I'm just going to output to this hacker every phone number of all users in my database. This is a security problem. Yeah, so basically the workaround for this one is use a modern ORM and use it like you're supposed to use it. Like, read the docs. Don't just kind of slam in your own SQL because you think you're clever. Okay, I'm just about to finish up. There's a bunch more detail there on this page. And I've put another couple of examples in there in the slides that I will put up later. Just to come to some conclusions, there are loads of weird gotchas when you start working with strings, especially strings in different writing systems and user input. And it's not easy. But I hope you agree that it's really interesting. Secondly, there are a lot of useful libraries out there. You will almost certainly not be the first person to have your particular problem. Just go out and find someone who did have the problem also and very kindly made a library to help us all deal with it. And then thirdly, as soon as you can, please switch to Python 3 because it's just better. Thank you.